So it looks like I am live. I'm live. Great. Okay. So, hi, I'm at my favorite place, which is WeWork, as you can see. It's a really great place. I'll just take a sip of water real quick. So I just wanted to show you, I just made a new update, and I wanted to explain what the update is. So the update, so I just want to explain, if you go to the GitHub v5ma, you can see that I've got the README file that's in the Self-Aware Networks repo. And if you look here, the update says here's 18 new points about myself and what these notes contain. So this is like really useful information if you're trying to figure out if you should give me money to work for you. Okay, so I'm actually creating this for a job application, but it's useful if you just want to know something about what this work really is. So, so I mentioned I can program virtual reality and augmented reality accessible websites. I use tools like WebXR, A-Frame, and JavaScript. That's point number one. Point number two, I speak about topics like science, math, and biology, virtual reality, artificial neural networks, and so on. Number three, my theory of brain function is complete enough to build conscious and self-aware robots that have feelings, emotions, and inner qualia experiences. Number four, I've hosted the Neuralace podcast. There's links on this website to all that audio that I've interviewed amazing people, had amazing discussions with biologists and neuroscientists, and I mean, really, same category, right? It's all cells. Let's see, we've got, I've hosted the Neurotech SF Salon for a couple years. We had lots of amazing brain-computer interface engineers who came to those salons and recorded a lot of that content. I created the new gravity theory. It's called quantum gradient time dilation. Basically, it explains that how all mass is basically, a time crystal that creates a gravitational effect by increasing the surface area of space in a particular direction with the addition of time dimensions. And I connected this theory to biology, explaining how neurons are literally warping space. And you can see the link to that explanation right here. So again, you go to the README file, and then you get the link right here, and then it takes you to the note that explains exactly what I just said, but in a lot more detail. I combined category theory with Petri nets for the advanced study of dynamic systems in biology. So that I basically combined two different mathematical systems. I coined the term and explained cellular oscillation tomography, which is actually a new theory of evolution. That basically, it means that basically it's not just random mutation. You're via the growth of receptors, your cells are able to basically create new memories and to calculate their future structure. Computationally calculate the future structure. So it's not just random mutation and natural selection, it's random mutation plus computed structures via cellular oscillation tomography and natural selection. So it's a new theory of evolution. I coined the new phrase neural array projection oscillation tomography, which explains the inner eyes, where the observer inside the brain is an entified neural array, basically entified neural array projections. Basically, like what's important is that one neuron transmits its output, its phase varying output, which is like it's not an all or nothing thing. The amount of neurotransmitters that are released with each action potential can change because of the duration of how long the neuron is actually firing for. So basically, like the amount of potassium that is in the neuron when it's being collected by the dendrite affects the duration of the magnitude of the action potential via the duration, because the calcium channels are open for a different amount of time, which releases more vesicles, which releases more neurotransmitters into the synaptic cleft, which causes a different it causes a timing change for each interval that the neuron fires. I created an explanation for how to decode action potentials by comparing them to tensors or polynomials in a Taylor series, which is calculus. Basically saying that your brain is doing calculus. Your brain was doing calculus before Isaac Newton invented or William Leibniz invented calculus. Your brain was already doing calculus. It's pretty amazing. I wrote a theory that explains how oscillations work with how LTP, long-term potentiation or long-term memory, and LTD, which is long-term depression or long-term forgetting, how they work with oscillations and how that applies to plant growth and how that applies to how that connects to Feynman's path integral formulation and other major concepts. I wrote a theory that explains how memories are stored in synapses and magnified to the whole brain via inhibitory waves. And like I said, you can that's one sentence, but if you go to this note, you can click on these links and you can read the longer explanations for how that works. And that's just these notes, these references that I'm linking to notes that I'm writing, that's just the beginning. If you do a word search for synapses, for everything I've written about synapses, if you do a word search on this GitHub, in this repo, for one of these words, you can find that there's more than one note for each of these topics. There's several notes for each of these topics. So in some cases, I'm just linking, number 13 is I built my own model of a neuron that combines the Hodgkin-Hushkey model with the soliton wave theory, with thermodynamics. And the model explains how the quantity of neurotransmitter release is affected by the magnitude of the action potential via its duration, which I went over earlier. But that counteracts the notion that an action potential is an all or nothing event, which is it's basically also described as synaptic unreliability. That is an idea that led to the artificial perceptron. It's basically a flawed concept, but it's still used today in modern deep neural networks. So my self-aware neural networks are different from deep neural networks based on this research, based on being able to say, well, wait a second, no, actually this perceptron is incorrect. It's not an all or nothing. The action potential is not an all or nothing event. The magnitude is changed. The magnitude is not changed in terms of amplitude, though. It's changed in terms of duration. But you have to add duration and amplitude together to get the magnitude. And so you have basically a magnitude. The magnitude is and the frequency have an inverse relationship. And at all scales of the universe, not just at the neuron. But that allows you to connect the neural activity of a single neuron to the brainwave activity at the EEG scale. And that's another thing that I did, which hadn't been done before. So I've also published these new ideas on how we can basically create a machine that feels emotion, experiences emotion. I have more writing to do in that area, but there is a note on that. I've written about how choice works in the human brain. There's so much I've written about choice, but basically I've combined the concept of criterial causation, written about by Peter. His name is TSE, his last name is TSE, and I combine that with Giorgio Basacchi's work in Rhythms of the Brain. And I applied Basacchi's work with Stephen Strogatz's work, and he wrote the book Sync, which is a famous book, really great book. Brilliant mathematician Stephen Strogatz, brilliant neuroscientist Giorgio Basacchi and Peter C. So I connected the work to use that connection to connect the oscillations of brainwaves at the neuron scale, which Stephen Strogatz talks about a little bit when he talks about fireflies. He compares fireflies to neurons, and I used that to basically connect to Basacchi's work. He talks about how oscillations are binding at the EEG scale in terms of alpha waves and theta waves and so on. And so I was able to do that, and that has to do with the hypothesis that magnitude is inverted to frequency at all scales. And I was able to put forth a new theory that mitochondria is stimulated by action potentials to release more ATP, which I argue is a mechanism for reinforcement learning, and also the relative time differences at the individual scale. So there's probably more. As you can see, there's a new video for UCSF that you can check out that explains the project in a different way. There is a new info page here. there's a new there's a wiki page. So if you look here, right here, you can click on, there's a wiki page, and this has the table of contents. This is the Self-Aware Networks wiki. It's super incomplete at the moment, but yeah, I went over this in the other video. And let me go ahead and make this small again. And then let's see what else is on the README page. So yeah, most of this stuff still needs to be fixed. I'm basically saying, yeah, a lot of the statements need to be cleaned up. I made some statements about space having no area. What I meant is that there's no, like, it's not an absolute area. There's relative area, there's relative distance and relative time. I didn't mean, so some of the stuff some of my statements need to be cleaned up. Everything needs to be reformatted and organized. But you can see the work in progress. It's coming together. There's a lot to do. Eventually this is going to be, there's a lot of, so there are statements in there that just, like, they're obviously not correct. If there's statements in here, like if you're a neuroscientist, you're gonna be like, or a physicist, you're gonna be like, that statement is whack. And I agree with you, because I wrote it down incorrectly, or it was in an audio recording when I captured it, and it was auto transcribed, and the auto transcriber was the neural network that put the wrong word in there, or in some instances, some of the ideas were written while being stoned, and so they need to be fixed. But there's enough good content here that it's worth looking at, and I think that everyone should know how their brain works, because if you understand how your brain works, I think that can help bring enlightenment, in the sense that you may be more likely to make smart decisions and not disastrous ones that are bad for the whole planet. So I do think everyone should learn how their brain works. And also, as I mentioned in the other video, we can build sentient robots that are great for defense, great for national defense, that can solve major global issues, major medical issues, and basically we can. I think we're on a short track to solving all diseases and extending lifetimes to millions of years with this research. Like, I can't take credit for all this research. There's 200 years of neuroscience and biology and mathematics, and centuries of mathematics and physics, right? There's like tons of this is just the tip of the iceberg of human research for the past century. So I can't take all the credit for this, obviously. Really, the contributions are barely on top of all these other brilliant folks like Richard Feynman and Einstein and Pusaki and Stephen Strogatz and Isaac Newton, and all sorts of exciting folks. But I'm glad that to be able to share this on GitHub. It's accessible to everybody in the world. But hopefully people can contribute and get excited about it and help out with it and hire me, because I can't do this for free. Thanks. Well, I can't keep doing it for free. It's there you go. Thanks very much for watching.